Aaron Ackerman. I work locally here in Minneapolis in Northeast at Code42. I work on JavaScript UI projects there, and we've been working on some new projects, and I've gotten to actually work on modern tooling for single-page applications, and it's been very nice to be able to work on a greenfield project instead of some of the other projects that we have at the company that have you could consider them legacy because they've existed for 5 years and I didn't start the project and I don't know all the internals. So there's actually a lot of people here. There's overflowing. It's not even standing. It's pretty much standing room only. So please bear with me. If you have any questions, please shout them out because otherwise this is going to be really boring talk. A lot of this is actually examples that I wrote. So we'll go through this a little bit. I only have a few slides, and then we'll go through the examples and maybe some live coding. So usually when you're talking about JavaScript application tooling, you're talking about single-page apps where maybe you have just an HTML file and you're running from Nginx. You may be running a Rails server. You may be running whatever backend you want and serving a dynamic page and then building up your application from JavaScript from the front end. You may be doing like an isomorphic app using React or Ember.js on the back end and server-side rendering, and then taking that up with on the front end. So let's talk about single-page apps and tooling. So there are a lot of different types of tooling, and all the options are perfectly valid for you. You can have HTML files, one or many, with many unminified plain JavaScript, your own scripts that you've written, and external libraries. You can have one HTML file with one or few scripts concatenated together and minified. That'd be a little bit more professional. You could have async JavaScript loading with deferred loading. So you have an initial page load that loads a minimal set of JavaScript and then deferred loading of much more JavaScript. In your development process, you could have a file save and then you run a build process and then refresh. You could have a save with a watcher running in the background that auto rebuilds everything and then you refresh. You could have a save with an incremental rebuild and then refresh. A save with live reload, hot module replacement, and you could be using ES6 and modules and Sass and auto incremental rebuild. These are getting into the higher levels of more sophisticated tooling, but they're all perfectly valid if they work for your workflow. More recently, in the past couple of years, JavaScript has become more of a compiled to JavaScript language. So using the Babel project, you can write in ES6 JavaScript syntax, or you could use CoffeeScript, or you could use ClojureScript, Scala.js, or 100 other compile to JavaScript libraries. There's a compile from Go to JavaScript. There's compiled from pretty much anything to JavaScript. You can do it if you want. But we're going to be talking about compiling with ES6 syntax using the Babel project. So a few features of ES6 as opposed to ES5 or ES3 JavaScript. Class syntax. So instead of function constructors, you will be using a class keyword, class, and then the name of the class and a brace body with a class definition body. I forgot to mention this is a very advanced talk, so if anything is unclear, please ask me questions. Along with that class syntax, you get extends for subclassing and actually subclassing built-ins like built-in arrays and built-in objects. Module syntax for standard module syntax as opposed to a CommonJS or AMD module syntax. Fat arrow functions to give you lexical scope binding so you can avoid the var self equals this pattern and just use this in callbacks. Rest and spread syntax that you will, or var args in other languages. So you can replace array.prototype.slice.call on arguments for turning that arguments object into a real array. You can use rest arguments and get that as a real array. enhanced object literals, default parameters, destructuring generators, template strings, native promises. So instead of pulling in Bluebird or Q or RSVP as a promise library, promises are actually native to a JavaScript runtime. So these are available in the latest Chrome and Firefox and IE. So what kind of problems are we solving with the new syntax? So usually what you're getting is more terse syntax that's easier to understand, and it gets around some common JavaScript idioms in a much cleaner way. So usually you are able to write less, it's more understandable, you're not jumping through hoops to make things clear. And it also comes with standard patterns for JavaScript modules and standard patterns for modularizing code and importing code into from one file into a different file, which has historically been very complicated, and community solutions like common.js modules in Node and AMD that has been prevalent in the browser have been used. But instead we have import and export syntax to deal with modules. So most of my talk and what you're probably going to be interested in is the Babel project. Up until recently, maybe a month ago, it was called 6 to 5. So the main point was to translate ES6 syntax to ES5 syntax. To run in like IE 8 and above with newer syntax, but the project was renamed due to different constraints. It's more of any future JavaScript syntax compiling to a syntax that you could use in a browser today. Let's go here. There's actually like a REPL that you can use to output JavaScript like ES5 to ES6. Doesn't look like this is loading fast enough, so we'll have to move on. But the main premise of the Babel project is to take new features of the language and translate that to features that can run in a browser today. So we can look at a couple of the features that I talked about earlier. Fat arrow syntax allows you to define a function like this, where it has your arguments as in parens and with an equals and a greater than sign to signify the arrows, and an expression body. And if it's a single expression body, you can skip the braces and have an implicit return. If you have multiple statements, you'll need an explicit return and the explicit braces. We get lexical this syntax, so you can see inside this callback, or we don't have to use the var self equals this to get the correct name value here. This is the class syntax that I spoke about. If you're unfamiliar with it, it uses a class keyword and the name of your class, and optionally extending from a base class. It uses a constructor as the initializer, constructor method, and this is a class body, and it offers static methods, getters and setters, and super syntax. So you can actually call your super class in a defined way. Enhanced object literals that I spoke about, you could have like a single, you could in certain cases, you could have a list of variables and pass those into an object, and you can skip the keys. That's a new feature in ES6. So you could, if the variable is named the same as the key you want, you can skip the key and pass it in, and it'll look like an array. Computed or dynamic properties. So a variable can be computed inline where the key is, there are braces on either side of the key, so you could use something more complicated, an evaluated string as opposed to a static string in, as object keys. We have short function syntax. So for functions, you can ignore the key. Well, the key is the name of the function, have parens, and then skip the function keyword and followed with the function body. Template strings are a standard way to do string interpolation in ES6. We could see name of Bob here and time of today, using backticks to surround the string that you're looking at, and $brace interpolation here. You can see that name will be inlined here and time will be inlined here. And these are expression bodies, so they actually take more than static variables. We could put date.now in here, and it'll get evaluated as an expression. There's also a prefix that you can put function keyword or a function reference at the start of a template literal, and this string will be, or the function will be evaluated, and the string will be the first argument to the function. I talked about destructuring. This allows you to have a return, this return value from this function can be destructured into these variables here. So here we're creating the variable op, LHS, and RHS, and you can assume that getAST_node returns an object where that has those specific keys, op, LHS, and RHS, and we're binding those variables to those values coming from getAST_node. We also get default parameters, so we can have avoid the object, params is equal to params or empty object syntax. I talked about rest and spread. It's easy to get the first variable and put all the rest of the variables in a second variable. So this ... syntax signifies that I want all of the rest, all the following arguments after the first one in this y variable. So y is going to be an array. Block scoped bindings. So inside of a set of braces, inside of a function, inside of an if or a for loop, we can use let instead of var, and the variable will only exist inside of that block. It won't get manually hoisted to the top of the function body like vars will today. We have a real constants in the language where it behaves the same as a let binding. It exists only in the scope of these braces, and outside of that scope it doesn't exist, and references to that variable will throw reference errors. Iterators and for of. So I assume everybody in here is probably familiar with the for in syntax, and you get for var x of object or array, and you are actually getting the key as that value. For for var of, or a for of loop will actually give you the value, which is usually what you want. So for objects, it'll give you the object, the value of the keys over and over, and for arrays, it will give you the value of the arrays. So instead of maybe a for each or array.for each, you could use a for of and get the values, just as an easy thing. Module syntax. So You can use, import star as math from libstar from your own math library. You can use destructuring as imports. So assuming that this math library returned an object that had a sum method and a pi value, we can import just those values from here and use those here. Most of that is just new syntax that's coming to browsers. Some of this is available actually right now. Most of what I am interested in is actually using this in the browsers today. So you can see this is a ES6 compatibility table. If you go to this, if you search Google for ES6 compat table, the first result is probably going to be this page. And you can see these are the features on the left of ES6 JavaScript, and on the right we have a big grid of browsers and listing how much does this runtime actually support the features that we're wanting or we're looking for from this list. So you can see the IE technical preview, the Spartan browser that's coming in IE 10 or Windows 10 is actually at 73%. It covers 73% of the spec'd out features. The Babel project actually covers 75% of the features. So it actually covers more features than are actually available in the most modern browsers. So this 75% gets you in IE 10. It gets you from 3% to 75%, where you can use 75% of the ES6 features by transpiling with Babel from ES6 to ES5. You can see I'm running in Chrome 41 right now, and Chrome 41 only has 40%. It supports some for-of loops. It doesn't support REST or spread. It doesn't support default function parameters. But we can see that using the Babel project, we can actually use those, and it will be transpiled into or compiled into a version that is usable today. So let's get into, I've been talking for a while. Let's get into some examples. This is one of my more complicated examples. This is using whole host of different projects. I have a GitHub repo and GitHub at github.com/aackerman/minibar10. All of my examples are hosted here, so you can see examples of using Babel with Browserify, ES Lint, Grunt, Gulp, Jasmine, Mocha, Node, NPM, React, and Webpack. So we've got a lot here, a lot of examples, and I maybe or maybe not have time to go over all the examples, but this is an important location if you're interested in looking at the examples and interested in getting involved in using the Babel project. So this page that I'm actually running is this Babel with React project. It's using React and Webpack, Karma, Jasmine with Phantom.js 2, and Babel itself. So here we can put in a GitHub username and query the GitHub API. Click Find, and it should come up with my username. We can get Tony C, and we can get Tony's image right there. If we do nothing, well, it's supposed to have a place kitten, but apparently my 404 method isn't working. So let's look at what this looks like. This is a little bit of a more complicated example using React and Webpack and Babel. If you're unfamiliar with Webpack, it's a very good a module compiler to compile CommonJS syntax or AMD syntax into a single script, or multiple scripts. It's a pretty much all-in-one solution similar to it is a competing project with Browserify that offers compile this single entry point JavaScript file and all of its dependencies into one file. So our entry point is source main, and we're building into we're outputting into build main, and we're using this Babel loader as a dependency. Our source is here, so we go into main. We're importing React from an npm module. We're importing my app component from this file, this app.js file here. And this is a syntax to use a Webpack file loader to actually copy my index.html file. This one is the least important. We're using React to render into a DOM element in this HTML file that is presented to the browser. And we are using some React to create a component with a render method to render this HTML into the DOM. So when we submit the form, it goes through this handle submit, gets the username, looks up the user, and sets the image URL to be the image of from the avatar or from a place kitten. So you can see that I'm actually using a lot of newer syntax here, and we are able to get that compiled down into the main.js that we're actually running in the browser. So we can see two different kind of versions. This main.js and this main.js. So our entry point is this specific file, and we're importing other libraries using Webpack to actually walk the dependency graph, read the syntax of the file, and determine what are all the dependencies of this file, what are all the dependencies of all the other files, and compile that to one main.js build file. And this is essentially an ES5 compatible output that would be able to run in an older version of Chrome that didn't support any features of ES6, or this would probably run in IE10, as opposed to none of this syntax is actually natively supported, but we are compiling to a version that can be supported in browsers today.
How far back does Internet Explorer ES5 support go?
ES5 is supported in IE8, and it's a little bit quirky, but the Babel project will actually, if you use a subset of the ES6 features, can be run in IE8 and IE9. You'll get the most functionality if you're able to only support, if you only need to support IE10 and above. So if you end up leaving this talk and you're looking to work with Babel in one of your projects at work or in one of your side projects, you can go to this minibar 10 repo. Let's see. So I'm in my minibar 10 repo, and I can cd into one of these directories. I can cd into Babel with ES Lint. And this is showing some integration with ES Lint. I wrote some poor code here, and ES Lint is going to tell me exactly what is wrong with my code. This is specifically using let variables, fat arrow syntax, and REST arguments. So I'm adding as many numbers as you want together, and this is pretty much a reduce. Add all these numbers together. So in this directory, if I run ESLint on my file, it's going to tell me, I have two things. And add is defined and never used, so I didn't actually export it. Either you have to use it as a global or not use it. And my return statement should not use this terse syntax where I'm actually adding to the memoized variable and returning at the same time. ES Lint doesn't like that. So, but you'll notice that it didn't actually complain about any of the ES6 syntax. We're using the Babel project, ES Lint, and Babel ES Lint. So we have an ES Lint RC that's using the specific parser that is able to kind of pre-process this file with Babel and then go over it with ES Lint. So we can lint our code the way we want to write it and still work with the modern tools that are available, so we can keep code quality high and not ignore these projects that you need. You need a linter, or you usually will want a linter to make sure that you're not making dumb mistakes in your project. All right. The debugging support is pretty much the same as otherwise. If you're using my experience, pretty good. I mean, using Chrome and source maps. Source maps pretty much solve the problem. So you're looking at the code that you wrote, and then you're debugging with that as opposed to the compiled version. And one of the main features of Babel as opposed to other projects like Tresor, there's a project from Google called the Tresor compiler, which has similar goals. It outputs very, you could say it's not, the syntax isn't really nice to look at. You can see that this syntax is pretty close to maybe what you would have written had you been writing it in ES5 instead of ES6. You would write, instead of import React from React, I would say var React is equal to require React, and as a common JS format, and then compile that to a single file. Instead of a fat arrow syntax, you would use var. You would get this reference and just use that. So there's probably right here. In this specific instance, in the source code, I had used a fat arrow syntax to close over this promise. Babel interpreted that I wanted a lexical scope binding, and it created a reference, and I'm actually using that reference, transparently. So I don't have to make the var self equals this or var that equals this. The compiler is handling that for me, so I don't have to worry about it. So the main benefits are cleanliness of code and real modules. If you're using a Browserify or Webpack as your solution for compiling scripts together, a lot of these tools are very similar in the same vein. You could use Grunt or Gulp. You could use ES Lint or JS Hint. You could use Jasmine or Mocha. You could use React or whatever else, Angular or Ember. You could use Webpack or Browserify. And these, I try to present, most of these projects have the flip side of the coin, and I tried to present all of them despite, what are my preferences. And my preferences are actually in this, Babel with React project. I put everything together that would be my preference and put that into a single example. You can see here I have a simple example of using Babel with npm scripts. This only depends on the Babel CLI, and with this specific example, you can run Babel on add.js and output a bundle, and we could do that right now. So that took these same add method that we were looking at before, and that output into a single other file. So you can see this is the equivalence of the two. We compiled this ES6 version here to this ES5 version here. It iterates over the arguments object to get the arguments object into a real array. And this is pretty much exactly the same method that I had written aside from the fat arrow syntax. Does anybody have any questions, or would you still like to see more examples? Yes?
How does the construction work with the oblification process? Are we seeing any problems with variable naming and everything?
No, I haven't seen any. You know, most people are going to use either the Google Closure compiler or they're going to use Uglify JS, and I haven't seen any problems with that. Yes?
Been hearing about ES 2015, ES 2016, then ES6, ES7. As far as you know, are those just synonyms, or are we switching from an integer counting system to a rolling, like annual kind of ES?
Yes. So, you know, for a long time, for years, it was called ES6. And the committee that actually specifies JavaScript is called, they're part of the ECMA International Organization, and the committee is called TC39. And they have a mailing list called ES Discuss. And on their mailing list, they have talked about, you know, renaming ES6 to ES 2015. And that it's some, you know, if you're on the bleeding edge of JavaScript and you're following the people who write the spec on Twitter, they're talking about it, and they're trying to rebrand it. But you know, in all reality, people are probably not going to call it ES 2015, even though that's what the spec calls it, because it's hard to change everybody's mind and what they're going to say. So you know, ES6, ES 2015, they are synonyms. They're completely equal. And it will probably likely move to a rolling spec where it's not a big bang, you know, we write this entire large spec over the span of several years. They're probably going to move to a feature type system where, you know, they specify a feature, and as soon as that feature is done, it's released to browser implementers, and they say, yes, this is complete. You can implement this based on our specification, as opposed to having a large bundle of features that get specified all at once. They're probably going to move to a model of similar to CSS or HTML, where they're specifying single features instead of big bundles of features. Yes?
Kind of along these lines, like, are there any kind of, it seems like Babel is like kind of like an all or nothing thing, right? It goes like, you know, from ES6 to ES5. Like, is there, like, what about like Chrome 50 that does support a bunch of this stuff? Like, how do you sort of let the browser handle it natively if you want?
Well, so I don't think that's actually an issue yet. It will become an issue in a year or 2 years. And I assume by that time the project will have evolved and allow you to exclude. You know, I'm actually targeting the most modern browsers, so only polyfill these features, because these are the newer ones that I need. And newer features are actually in Babel right now. So you know, ES7 or ES 2016 features are available as experimental flags. So those are coming as well. So they're not on all the time, but you can add a flag. You know, I want to use rest and spread on objects instead of arrays. That's a feature that is supported by a flag, not completely specified. There are proposals for that to be added to the specification. Yes.
Quick question. What's been your team's reaction for readability, like just bad arrow versus function? Our monkey brains are so deeply ingrained with Sublime and the color coding with function, scan through gobs of code.
Mm-hmm.
Do you find that it's a little more difficult to spot those kind of things when working with ES6?
So personally, no. There's specifically for Sublime Text, there's a Babel Sublime highlighter that will highlight code that you would be writing and compiling with Babel if it's in ES6. And I'm actually using it right now. You can see I'm using the Babel highlighter. For other code IDEs like WebStorm or IntelliJ, you might have problems with highlighting and using ES6 where they only have ES5 compatible highlighters. You might see problems there. But you won't if you use a specific highlighter in Sublime Text. You might also have problems with highlighters in Vim or Emacs.
Are there any performance issues compared to handcrafted ES6 code? Or ES5 code?
I haven't run into any. But as with all performance issues, when they happen, deal with them. Don't try to pre-optimize.
How does that Babel compare to like ES6 shimming? So using shims to actually have the includes in there instead of being compiled.
So Babel is kind of a two-sided coin. It offers a transpilation for some features, and for other features, like there's object.assign, which is synonymous or similar to _.extend, merging objects together, at least in a shallow way. Babel will use the core JS project to actually shim those. And that's an optional thing. One other interesting thing that I didn't actually show yet, you can use Babel with Node. So I have a Babel with Node example that's depending on Babel and Express. In the index.js, I require Babel/register, and that will do some magic to work with the require statement. So any modules that I require after that are .js files, it will transform them into ES5 compatible, something that will run inside Node.js. So you can see here, I'm requiring Babel register and requiring main. And this is my main where I'm actually importing Express with ES6 syntax. I'm using fat arrows, and I'm using Destructuring here to get the address and the port of the server that we're listening to. So it's easy to use in Node as well. Sure. Are you interested in one in specific?
No.
Okay, all right. Just a quick question. How many of you in the room are using any one of the tools on this list? At least one of them? Not specifically Babel, but Browserify, ES Lint, Grunt, Gulp. Okay. Is there any? Name one that you want to see. Jasmine. Okay, we'll look at Jasmine. This is actually not Jasmine by itself, but I'm showing an example of using Jasmine with the Karma runner as a Babel preprocessor. So here is our Karma conf. We're getting all the files in source and all the files in test, and we're using the Jasmine framework. and we're running the Babel preprocessor on all of my source and test files, and getting inline source maps and rewriting the file. We're running in Phantom.js 2. This is my same add function and add test. Both of these are using ES6 syntax, and we can see that run. Oh, so ran really fast. It will incur some overhead in testing and pre-processing time. It's not free, right? It's quick, but it will increase the build time of your project. I have a project at work that I'm working on. We're using React and Webpack and Karma and Jasmine. Using Babel probably increases the build concatenation time by a factor of 3. It's instead of 3 seconds, it's 10 seconds. Nothing world-shattering. We have a gulp file that will look like this, dealing with source maps, a Babel, and concatenation. So this will take all the files from SRC and run them through source maps, concatenate them all into all.js, run them through Babel, and write source maps to dist. So when this is my app. It has let syntax and enhanced object literal syntax, and we run that through all, and we get an ES5 version with a source map. We can look at Grunt. It's very similar. Anybody have any questions before I move on? Okay.
I just have a question on Gulp and the Jasmine stuff.
Okay.
Is that like continuous too? Like, does the Jasmine pre-process when you update individual test files like
Oh yeah.
you normally would in a
So I'm actually still running this.
Okay. Yep.
We'll just do. Now we're writing 2 tests. And if I change that, we can see the failure. Expected 1 equal 4. So specifically with this Jasmine, or using Karma, it'll be set up to run as a watcher as opposed to a single run. So I think I showed pretty much everything except Webpack and Mocha. Is anybody interested in those, or I think I'm almost out of time. All right. If there are no questions, I think we can end a couple minutes early.